This is the Bed Bug Specialist podcast. This podcast is created to help educate the public and pest control professionals on bed bug news, facts, tools, and treatment methods. Follow, like, and share this podcast, and if you give us a 5-star review on iTunes, you'll be entered in a monthly drawing to win a gift valued at $50. Find us on iTunes and Stitcher, Google Music, Spotify, Podbean, and iHeartRadio. You can contact the show at 918-960-0829 or email us at podcast@TulsaBedBugSpecialists.com. Our Twitter is @TulsaBedBug. Our website, TulsaBedBugSpecialists.com. And you can also find this podcast on YouTube. Now, here's today's episode.
Hey guys, this is another episode about boric acid, and in this episode we're going to learn about boric acid and about people that are studying it with the effects of bed bugs and trying to develop different there's different manufacturers that are trying to develop different formulations to kill bed bugs, and there's research on it. So here's an article, a recorded article on bed bugs and boric acid, their effects, and short episode. Any questions, concerns, comments, email us, get with us, and we'll discuss it on the next episode. Thanks, guys. And here's the article.
Boric acid kills bed bugs, but only when they eat it, by Andrew Porterfield. Editor's note. This article originally appeared in Etymology Today, a project of the Etymology Society of America with the goal of reporting interesting discoveries in the world of insect science and news from various etymological societies. To learn more, visit www.entomologytoday.org. As scientists try to determine a reason for bed bugs, Semex ludularius, researchers, pest management professionals, and members of the public have searched through a number of eradication methods, including chemical pesticides and other treatments, with varying and often negligible success. One common treatment has been the use of boric acid on bed bugs, as a dust, spray, bait, paste, gel, or liquid. Dust may be the most common boric acid treatment, but its efficiency is not known. Some pest control advisors and agricultural extension agencies have even recommended not using boric acid at all. To help determine the efficiency of boric acid on C. lectularius, a team from North Carolina State University, led by entomology professor Kobe Shaw, Ph.D., examined 2 ways to deliver boric acid: contact with dust or by ingestion. They also compared results to boric acid treatments on common German cockroaches, Blatella germanica, which boric acid can kill by both routes. In a study published in September in the Journal of Economic Entomology, Shaw and his team report that boric acid can kill a significant number of bed bugs, but only if the chemical is ingested. Bedbugs that eat boric acid at concentrations greater than 2% die quickly, and concentrations as low as 0.5% cause 100% die-offs, although at a slower pace. However, external contact with high concentrations of boric acid dust did not have a significant effect on bedbugs. By comparison, boric acid effectively killed concentrations of German cockroaches regardless of the route of contact. The researchers conducted 4 experiments on the bedbugs and roaches. 1. The first experiment involved feeding boric acid to 10 adult male bedbugs at concentrations between 0 and 5%. The bedbugs were fed for 7 days. 2. The second experiment involved exposing bedbugs to boric acid and dust. Here, 118 starved and 120 fully fed bugs were placed inside dishes containing boric acid dust, and mortality was measured for 14 days. In the second experiment, the researchers also looked at whether boric acid particle size had any effect on bed bug mortality, homogenizing some boric acid powders. 3. The third experiment involved exposing German cockroaches to boric acid dust. One group of roaches had glued mouthparts to prevent ingestion, while the second group was free to feed. 4. The fourth experiment involved injecting boric acid directly into the bedbug's body, the hemocoel, to determine toxicity of the chemical to bedbugs. Bedbugs had no aversion to feeding on boric acid at concentrations up to 2%, though the number of fully engorged bugs dropped to 80% at 5% concentrations. Simple exposure only to the dust showed a 33% mortality rate among bedbugs after 14 days of observation. Increasing concentrations tenfold only increased unfed male mortality by 10%, and there was no difference between fed and unfed bugs, nor did reducing the size of boric acid particles have any effect on bedbug mortality. In fact, more than 85% of fed bedbugs survived external boric acid exposure. Injecting bedbugs did cause high mortality rates, up to 95% at higher concentrations, indicating a toxicity of boric acid to bedbugs that the insect's cuticle is effective at staving off. Ingestion, by comparison, was easily induced in bedbugs and highly effective at killing the bugs. A single blood meal with 0.5% boric acid killed 80% of all bedbugs in 7 days. Concentrations above 1% killed all bedbugs within 4 days. By also testing B. germanica, which can be killed by boric acid ingestion or exposure, the researchers found some clues as to how boric acid may work on insects. It appears that this otherwise insecticide-susceptible strain of bedbugs possesses mechanisms that prevent boric acid from compromising or penetrating the cuticular barrier, the researchers write. Exactly how boric acid does its job remains a mystery, which presents challenges in designing baits to attract and kill bedbugs. But boric acid is a preferable chemical candidate for use in bedbug baits since it is soluble and stable in water, is not as toxic to mammals as other chemicals, is relatively low cost, and doesn't appear to trigger resistance by insects. As for the use of boric acid in dust applications, though, the study shows such efforts are likely to be minimally effective against bedbugs. The researchers note that boric acid is widely available to consumers and PMPs and is effective against other urban pests, hence its common use. But for managing bedbugs, methods to induce ingestion of boric acid will need to be devised. Andrew Porterfield is a writer, editor, and communications consultant for academic institutions, companies, and nonprofits in the life sciences.